All right, we're back. Number 12. Catherine ate lunch at a restaurant. The bill was $125. Wow, Catherine ate lunch by herself? $125. That's a really expensive restaurant. If she left a tip of 12%, how much was the tip in dollars? $125 for one person? That restaurant must be the most expensive restaurant in America. I'll tell you what. Okay, if she left a tip of 12%, how much was the tip in dollars? Okay, so we want to know just how much the tip is. So if we go back to think about this problem, where we just wanted the dollar amount of the tip, remember what we did? We just multiplied the total bill times the sales tax number without the 1 in front. That gave us the dollar amount of this. So we can do both ways just to make sure we're right. So it's $125 times 0.12, because that will give us just the tip dollar amount. And so 125 times 0.12, that's $15. That was the tip. Now let's just go ahead and double check ourselves, because there's a lot of formulas happening. Well, what if I wanted to know the total cost of her bill, including the tip? And I want to know the number amount, the dollar amount of how much she had to pay. Then I would do 125 times the quantity of 1 plus 0.12, because that's going to give us the total amount of money Catherine has to spend in order to get out of that restaurant without going to jail, right? For like not paying the bill. So we'll do 125 times 1.12, which is $140. That's how much she has to pay for the entire lunch, which makes sense, because if the tip amount was $15, right, and her bill was $125, we would add $125 plus 15 to get $140, which is what we got anyway. Now, again, the question is asking us for how much was the tip only, which is $15. Okay, let's keep going. All right. Find the selling price after applying the discount and or markup. Type in money form. I don't know what that means. I don't know. I have no idea what that means. This is the first time I've ever seen that. Okay. So the original cost of this item was $199.95. There was a markup of 85% and then a discount of 40%. We cannot apply them at the same time. So if the markup was 85 and the discount was 40, 85 minus 40 is 45. So we could just apply the 45 to this number, right? No, it's wrong. We have to do one at a time. And I know that's annoying, but we have to do one at a time. So we're going to do the markup first, because that's what happened first. So we're going to have 199.95 times 1.85. Right, I've got to apply the markup first. I can't do these simultaneously. I can't put them all together. 199.95 times 1.85. Okay, so let's make this in dollar amounts. Right, we can't have all these decimals if we're talking about dollars. So this is going to be $369.91 if I'm rounding. That is the markup cost, the total markup cost, like how much more or how much this item is going to cost her. But now let's apply the discount of 40% to this number. So I'm going to multiply 369.91 times 1 minus 0.4. And why am I doing that? Well, because the discount is 40%. So remember, discounts are subtraction. So I'm going to do this whole thing in the calculator. 369.91 parentheses 1 minus 0.4 parentheses. Okay, let's do that. So we get 369.91 times 1 minus 0.4. 221.95. So we got $221.95. That's going to be our final answer for that problem. All right, good. Okay, 14. Nancy is buying a new pair of boots. The store is having a sale, and all boots are 20% off. Nice, 20% is a lot. Okay, so A, choose an expression that can represent the sale price of the boots, where X is the original price of the boots. Okay, so if X is the original price of the boots, this would be a drop down, but I don't have it. Well, we know that it's 20% off, and the discount formula is going to be P times the 1 minus the rate. All right, well, we don't know the original cost of the boots, but we can say that that's X. So P is X here, all right? And then we can say times 1 minus 0.2, because we know the sale price or the discount price. So this is going to be the expression that represents that. Or X is going to be what times 0.8, because 1 minus 0.2 is 0.8. So either of these are going to work fine for me, okay? So part B says, this means that the sale price of the boots is blank of the original cost. Okay, this is a little weird. If you had the drop down, you'd be able to see it better. Oh, you do. Hello. Okay, so 0.8x, yeah, because x times 0.8 is 0.8x. And now, the sale price of the boots is blank of the original cost. This is weird. We don't talk about this a lot. So if it's 20% off the cost, we still have to pay 80% of the total. So if something's 20% off, we still have to pay 80% of the total. And we'll talk a little bit more about that on Monday. Okay. All right. 15. Okay, so now we're going to get back into the dilations type stuff, the scale factors. Triangle S and triangle L are scaled copies of one another. Okay, scaled copies means they have some kind of similarity. What is the scale factor from S to L? Okay, so there's no numbers here, but we can look at and count the boxes or count how many or how long a side is. We don't like to count diagonals because it's very difficult to count diagonals, but we can count the bottom. I see 2 boxes here, so that's 2. L has 1, 2, 3, 4, so that's 4. So what was the multiplier? What was the scale factor? Now remember, it's very easy on this one because we can just say 2 times 2 is 4, so the scale factor is 2, which is correct. But sometimes the numbers look funky. The rule is you take the second number and you divide it by the first number. That's the scale factor. So in this case, we would do 4 divided by 2, which is 2. Done deal. All right. What is the scale factor from L to S? Okay. So what if I went from L to S? That switches the order. If I went from S to L, it got bigger by a scale factor of 2. But now it wants to switch the order. So if I go from the bigger triangle to the smaller triangle, it got smaller. So I'm going to do the same rule. The second number, in this case, which is 2, divided by the first number, in this case, which is 4. So 2 divided by 4 is 1/2. So the scale factor from the other way around is 1/2. Triangle M is also a scaled copy of S. I don't see triangle M. I'm stupid. The scale factor from S to M is 3/2. What is the scale factor from M to S? I don't even know what you're talking about. So let's make a triangle M. The scale factor from S to M is 3/2. All right. Well, if the bottom is 2 and the scale factor is 3/2, scale factor of M, or one of the bottom sides of M, has to be 2 times 3/2. And 2 times 3/2 is just 3. So M is going to be a triangle that looks very similar to these, but it's going to have a bottom of 3. Okay? What is the scale factor from M to S? All right. So if we were to go backwards, I would say M is the first triangle and S is the second. So I'm going to use the rule. The second triangle's value divided by the first. So 2 divided by 3. So 2/3 is going to be the scale factor. Now that makes sense, and here's why. Let's go back to the first 2 problems. If I went from S to L, the scale factor was 2. But if I go backwards, using the same triangles, the scale factor must always be the reciprocal of that number. Remember, that's 2/1. If I just go backwards, I have to do the reciprocal of that. So it makes sense that if I'm using the same 2 letters, M and S, if going one way is 3/2, reversing it must be the reciprocal. You're welcome. 16. That was a long problem. Good God. All right. Find the scale factor of the dilation. Well, scale factors and dilations are the same thing. All right. ABC is a dilation of JHG. Okay. Don't worry about the center of origin stuff. That's stupid. So ABC is a dilation of. Okay, so ABC came second. So we went from JHG to ABC. So let's look. It looks like JHG is the smaller triangle, so we'll say it's the first triangle, and then this other triangle is the second. So we have to figure out what the scale factor was. So this is going to be challenging. And the reason for that is because we really don't have a straight edge that we can talk about here, right? But we have points, don't we? We have ordered pairs. Let's take this ordered pair of J. That ordered pair is 2, 2. So J is 2, 2. The second triangle, ABC, A, or point A, which corresponds to point J, right? If triangle 1 was kind of blown up and made bigger, A is going to be the new point that J was before. We just can't label them both J because that doesn't make sense. How could they both be the same point if they're not the same point? Right? Anyway, A is 4, 4. How did I get from J to A? And we did this in the very beginning of this unit. Well, we multiply. We figure out. So again, what did we multiply J by to get to A? Well, we multiply by 2. It's pretty clear. 2 times 2 is 4. But again, let's use the rule. We take the second set of numbers, or the second number, which is 4, divided by the first, which is 2. So the scale factor is 2. Now we can check that if we want to. I really would rather not. for time constraints. Let's move along. So the answer is 2. Okay. Using the scale factor in the middle column, find the missing values. All right. So if the scale factor is 1 to 6, 1 to 6. So for every 1 part, there's a scale factor of 6. So if the larger object is 60, that means that the smaller object is 10. Okay. So if the larger object is 60, the smaller object is 10. Okay. Scale factor of 3 to 10. Okay. So for every 3 parts, there's 120. So we're going to divide those numbers. 120 divided by 3 is 40. Using that same idea, because 40 represents 1, I'm going to multiply 10 times 40, which is 400. If the scale factor of the larger object is 95, we're going to divide that. So 95 divided by 5 is 19. Then we multiply that 19 times the 2, which is 38. Now, I want to say this. You are not going to have a problem like this on your test. This problem we have not talked about. We have never talked about. This is the first time you're seeing it in this unit. You will not see a problem like this on your test. However, you need to be aware of scale factors and their ratios. We have to figure out what 1 part represents, not 6. So if the larger object is 60, we divide the larger object by that scale factor, which is 10. Then we can apply it to the multiplication of the other scale. Same here. If the smaller object is 120, and that's 3 parts, we divide 120 by 3 to get 40. Then we use that 40 to multiply it by the other numbered factor to get 400. Same here. If 5 parts is 95, we divide 95 by 5 to get 19. And then we multiply 19 times 2 to get 38. All right? But again, you will not see that in your test. So don't be scared. 18. Rectangles P, Q, R, and S are scaled copies of one another. Okay, so they're all similar in some way. Decide if the scale factor from one to the other is greater than 1, equal to 1, or less than 1. So there's a table here. So from P to Q, certainly greater than 1, because it's bigger. Okay? Definitely not equal to, definitely not less than. From P to R, bigger, greater than 1. It got bigger. Q to S, smaller, less than 1. Q to R, bigger, greater than 1. S to P, they look just about the same. So we're going to say equal to 1. R to P, got smaller, less than 1. P to S, they look pretty much equal to me. I don't know why there's X's, that makes it weird. Okay, so if it's greater than 1, it got bigger. If it's less than 1, it got smaller. If it's equal to 1, it better be the same exact size. Better be. All right. Create a scaled copy using a scale factor of 4. You are going to have to do one of these on the test. So all we're going to do is look at how long the distances are of either horizontal lines or vertical lines, and then we're going to multiply by 4. So this is 2. So the new factor better be 2 times 4, which is 8. So let's go here. Let's go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's the new A. So A prime, B prime. This is 1. So we're going to go 1 times 4, which is 4. 1, 2, 3, 4. Okay, so that's A prime and D prime. Now, this one's weird. So if this was, we can do it this way because it's not too big. This is 1 diagonal. Like if this is 1 box, this is 1 diagonal. So we can multiply that 4, so we have to do 4 diagonals. Crap, I ran out of space. 1, 2, 3, 4. You get the idea, okay? And that's C prime. All we have to do is connect the dots. We don't have to count the rest. We can just connect the dots, right? So that looks like this is a much bigger, this is a 4 times the scale factor of that one, all right? Good deal. Okay, almost done. 2 triangles are scaled copies of one another. Find the scale factor. Okay. So it doesn't say to find x, which is weird. It just says find the scale factor. Okay. So if they're scaled copies, which it says they are, that means there's a similarity here. So I went from 4 to 10. Well, I don't know what that multiplier is right off the top of my head. So I'm going to take the second number, which is 10, divide it by the first, which is 4, and that's going to end up being 2.5. So the scale factor is 2.5. Or 5 over 2, whatever the drop down says on your test. Now it says, what's the value of x? Okay, well, that's interesting. So if the scale factor is 2.5, 5 over 2, then we can say 2.5 times x is 25. So we can go ahead and solve that if we want to. 2.5 times x equals 25. Divide by 2.5 on both sides. And I'm going to get x equals 10. So x is 10. Okay? We can do that. Right? Not bad. Or we could have just divided. We didn't have to set up an equation. Okay. All right. Jim drew a triangle with side lengths in inches of 3.5, 4 3/4, and 5 9/10. Riley made a scale drawing of Jim's triangle using a scale factor of 1/6, which list shows the side lengths in inches of the triangle Riley drew. Okay. So Jim has a triangle. This is Jim's triangle. Let's just use one of the side lengths at 3 1/2. Riley made a scale drawing of a scale factor of 1/6. So Riley's triangle is going to be a lot smaller because 1/6 is small. So I'm going to multiply this 3 1/2 by 1/6 to get this value. Okay, so let's go ahead and do that. 3 1/2 times 1/6 is 7/12. All right, so let's go ahead and look and see which of these choices has a 7/12 in it. A does, B does not. That's 4 and 7/12. It's the same. This doesn't, and that doesn't. Pretty easy. We got away with it. We don't have to do them all unless there was like 2 of these choices that had a 7/12 in it. Then we would have to go a little further. But I got lucky, and we'd say, oh, let's just multiply one of them by 1/6, and we got right. Okay. You might have to do more of that on the test. All right, 22. 2 trapezoids. They're scale copies of each other by a scale factor of 3. So clearly we multiplied this by 3 to get to that. Match the corresponding parts to each other. All right. Corresponding parts means it's the same location, just a different trapezoid. So side EF, and this is hard to see. This is EF. So this is its corresponding side, so that's WX. FG is this. So FG is XY. You have to keep the letters the same. They have to be in the same order. So like F to G is top to bottom. You got to do X to Y, top to bottom too. GH, right to left. YZ, right to left. HE, bottom left to top left. HE is ZW. Angle E, well, angle E is here, it's the same as angle W. Angle F is angle X. Angle G is angle Y, and angle H is angle Z. All right, so they have to be the corresponding parts. All right. If quadrilateral Q is a scaled copy of quadrilateral P, okay, so P started it, and Q's here, and it was a scale factor of 3, so we got a much bigger quadrilateral. What is the perimeter of Q? Ooh, tough. Perimeter means we got to add up all the sides, but first we need to find the sides. All right. Quadrilateral Q is a scaled copy of P with a scale factor of 3. So we got to multiply every one of these sides by 3. That's first. Okay. So then we have a 21. We have a 45. We have another 45. And then we have a 75. But it wants the perimeter. So I got to add up all these sides. Okay. So let's go ahead and do that. So we got a 45 plus a 21 plus a 75 plus a 45. That's going to be 186. So the perimeter is 186. Be careful. It's a tricky problem. Right. 2 more problems left. Angela drew the 2 rectangles shown. The second is a scale of the first. So first triangle, okay, there's our dimensions. Second rectangle, there's our dimensions. What's the scale factor that he did? Well, I don't know what 6.5 times some number is to get 16.25, but I do know to find scale factors. I take the second number, I divide it by the first. So let's do that. We're going to do 16.25 divided by 6.5. Right? So we got 16.25 divided by 6.5, which is going to be 2.5. And that is the scale factor. Now, let's just double check. Let's divide that number by that number just to make sure. It's always important to double check your work. And because it's the same ratio, we know it's clearly a scale drawing. All right. Scale factor of this house is 2 to 5 feet. That's the scale. So we went from 2 to 5 feet. Find the height of the original house and drop your answer below. 2 inches to 5 feet. Okay. So if it's 2 inches to 5 feet, I don't want to do this problem. This is a terrible problem. I say you don't do this problem because you're not going to see anything like this on your test at all. So the reality is that we're trying to change not only the scale factors, but we're trying to change the metric, right? So we're going from inches to feet, right? So, I mean, if 2 inches is 5 feet, then we can do a ratio here, but that's not really even what we want to do. Huh? Yeah, I want to skip this part. Goodbye.